Alright guys, today we're going to talk about the square root method for solving quadratics. So at this point the only way we can solve is either by factoring or by graphing. So you should recall the square root method, but just in case we're going to go over some important things. So first of all, how to simplify a square root. Okay, so there's 3 rules for simplifying square roots, and those rules are: first, there can be no perfect squares in the radicand. So remember, the radicand is what's underneath the radical. So let me actually show you some examples so we're not kind of lost. So like the square root of 8. 8 is the radicand, and the little symbol here is called the radical, and the number right here, which is not present for a square root, is called the index. Okay, so the square root of 8 is not simplified because 8 has a perfect square of 4. We could do 2 times 4, and 4 is a perfect square. So just kind of a quick reminder, your perfect squares are 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, and so on. Okay, so perfect squares. Okay, now the second thing is that there cannot be any fractions in the radicand. So for example, you could not have the square root of 2 over 9. That would not be simplified. Okay, and then finally, you cannot have radicals in the denominator of a fraction. So for example, you could not have 2 over the square root of 3. Okay, these are not simplified. However, these are simplified. 2 square root of 2 is simplified. You can have 2 underneath the radical because 2 does not have a perfect square in it. You could have the square root of 2 over 3. You can have 3 in the denominator, except for some reason I put 3 instead of 2. So let's try that again. Square root of 2 over 3, so it matches what I'm saying. So square root of 2 is okay, but 3 in the denominator is also okay. You just can't have that radical in the denominator. And then finally, if we wanted to fix 2 squared over the square root of 3, you could have 2 square root of 3 over 3. So these fix the problem with these first problems. So the square root of 8 would really be 2 square root of 2. The square root of 2 over 9 would really be the square root of 2 over 3. And 2 over the square root of 3 would be 2 square root of 3 over 3. Okay, so we're going to look at how to simplify these just in case you've forgotten. So number 1, we're going to start with the square root of 32. Now, some people can just see this and say, oh, the perfect square is, and tell me whatever it is. So, for example, the perfect square here, if you were to look for it, so you would know, hey, 2 goes into that, but so does 4, and so does 8. So what's the biggest perfect square? Well, the biggest perfect square is actually 16 times 2, because 16 times 2 is 32, and 16 is the biggest square. So then we would say, oh, okay, well, the square root of 16 times the square root of 2. We can actually break this apart. So the square root of 16 is 4, and then the square root of 2 cannot be simplified, so this would be our simplified expression. Now, if that is something that you struggle with, seeing the perfect squares, then let me show you another way you can go about it. Okay, you could break this down into its factors. So what that means is, what I just did is I just figured out multiples. So you could do like 1 times 32, 2 times 16, 4 times 8, and so on. You could do it that way. What you can also do is you could break this down into its perfect factors, meaning doing what I just did, but we're looking at prime numbers. So I could say, okay, 2 times 16. 2's prime, 16's not. 16 would be 4 times 4. 4 are not prime. So then we would do 2 times 2. So just a reminder, prime numbers are numbers that can only be divided by themselves, and 1. So 2 is prime, 3 is prime, 5, 7, 11, 13. These are prime numbers. So you could break this down into its prime factors, and then from there you could find the perfect pairs, because since this is a square root, we would need pairs of 2. So you could say, okay, there is a pair of 2, there's a pair of 2, so this would be the square root of 4, which is 2, the square root of 4, which is 2, and then the square root of 2. So notice you would get 2 times 2, which is 4, and then 2. So if you prefer to break it down to its prime factors, you may do that as well. Hopefully eventually you'll be able to just like identify the perfect square very quickly. Okay? So number 2, the square root of 63. So I want you to pause the video and see if you can break this down into its perfect squares, like its biggest perfect square, and simplify it. When you're ready to figure out the answer, turn the video back on. Alright, so the correct answer should be 3 squared is 7. So again, you could either break this down into its prime factors and see that 9, 3 times 3 would be the perfect square. Or you could just know that, hey, 9 is the biggest perfect square that goes into 63. So if you got this one right, give me a little smiley face in the bottom corner. If you got it wrong, give me a little sad face and then fix it for me, okay? So that we know that, hey, this is something we need to work on, okay? All right, so now we've looked at simplifying completely. Now we're going to look at some operations, okay? So we're going to add, we're going to subtract, we're going to multiply, and we're going to divide. Okay, so starting with adding, when we add these, we can only add like with like. Okay, so what I mean by that is you can only add the coefficients. Okay, they have to be the exact same radical. If the radicands are not the exact same, you cannot add them. So if you look here, notice I'm just adding the a and the c because the square root of b is the same. It has to be the same exact square root. So for example, looking at number 3, if I have 2 square root of 3 plus 3 square root of 2 plus 7 square root of 3. I need to know which of these are the exact same. So the ones that are the exact same are the ones that have the exact same radicand. So that means I need to look for a 3 and it has the exact same index. So that means it's a square root. Now these are all square roots, so that checks out. So we should see that 2 square root of 3 and 7 square root of 3 are the same. So what we are going to do is we are going to simply add their coefficients. So what that's going to look like is we're going to take 2 plus 7, and we're just going to keep the square root of 3. We're not going to touch it. It's just like like terms, like it's an x. So we're going to do 2 plus 7. Now that 3 square root of 2, there's nothing we can do with it. So we're just going to put plus 3 square root of 2 on the outside and just kind of let them hang around. Now I can add 2 plus 7. So 2 plus 7 is 9. So we'd have 9 square root of 3 plus 3 square root of 2. So this would be our simplified expression because we cannot combine them. We cannot take the square root of 3 and add it to the square root of 2. They're just not the same radicand. Okay, it's like adding x's and y's. You can't do it. Now it does not matter the order. You could have 3 square root of 2 plus 9 square root of 3. Okay, as long as you have both of them and they have the correct sign, you are allowed to do this, okay? So number 6, the square root of 12 minus 2 square root of 5 minus 5 square root of 3. Now when you first look at these, you're probably thinking, Miss Miller, these do not have any like radicals. And you're right, they don't. We have a 12, a 5, and a 3 as a radical, as our radicand, sorry. But you should notice that the square root of 12 can be simplified down. So the square root of 12 has a perfect square of 4. It's 4 times 3. So it's really 2 square root of 3 minus 2 square root of 5 plus 5 square root of 3, which should be like, oh look, now we have something that are alike. So we have 2 square root of 3 and positive 5 square root of 3. And notice I'm keeping the sign in front. Okay, I did the same thing up here. I was keeping that positive because it was in front. So now we can add the coefficients. So 2 plus 5 is 7 square root of 3, and then just tag on minus 2 square root of 5. And again, if you really wanted to, you could put negative 2 square root of 5 in front, but then you have to put plus 7 square root of 3. Okay? Yeah, so there's, oops. Oh, I made a mistake. I hope you caught me. I'm so sorry. This should not be plus. This should be minus. Oh no, oh no, oh no. Okay, so that's a good lesson right there. Double check your signs because that is the most common mistake. So this is going to change your answer from 7 square root of 3. So 2 minus 5 should be, I believe, negative 3. So if you caught that, good job. And watch me throughout the video. If I make a mistake, I want to know about it, okay? So make a little comment if you see something I messed up on. Okay, I'm human, I make mistakes. All right, any questions on adding and subtracting? If you have them, make a little, maybe a note on the side or make a little note on a sticky note or something, and we'll talk about it tomorrow. All right, so now multiplying square roots. Multiplying is a little more flexible. Multiplying, you do outside with outside, inside with inside. Okay, so it's kind of just a little bit of all kinds of craziness. So for example, if we had 2 square root of 3 times 3 square root of 6. Now, these do not have to be the same. Multiplying, just like multiplying variables, you don't have to have the same variables to multiply. Adding is the strict one. Adding and subtracting are very strict. Multiplying, much more flexible. So when we multiply these things, we're going to multiply the two outside numbers. So we're going to do 2 times 3. So 2 times 3 gets multiplied together. And then we're going to take and multiply our inside radicals. So 3 times 6. So we would have the square root of 3 times 6. Now, that's going to give us, well, 2 times 3 is 6. 3 times 6 is 18. And you might think, Miss Miller, I'm done. But no, you always have to check, make sure the inside number, the radicand, does not have any perfect squares. And if you will notice, 18 is 9 times 2. 9 is a perfect square, which means we have to do 6. 6 hangs around. 9, the perfect square of 9 is 3. So 3 comes on the outside, and then we have square root of 2. And then, of course, we would multiply 6 times 3. 6 times 3 is 18. So 18 square root of 2 is our final expression. So that's the simplified expression. Okay, so be very careful not to assume you're done before you are. Okay? So number 7, negative square root of 7 times 3 square root of 2. I want you to try this one. Okay, so pause the video, and when you're ready, turn it back on. All right, hopefully you're ready. So the answer to number 7 is negative 3 square root of 14. So again, if you got this one right, give me a little smiley face. If you got it wrong, give me a little frowny face. Not because I'm upset with you, but just so you know this is something I got to work on. Okay? All right, lastly, dividing square roots. Okay, so when we divide them, we have to make sure that we don't end up with a radical in the denominator or a fraction. Okay? So for example, if we had the square root of 7/4. Okay? Now the first thing I would look for is, can I divide 7/4? Does that simplify at all? In this case, it does not. So the next thing I would do is I would actually break this apart into the square root of 7 over the square root of 4. So this is a property that we have with radicals, where we can actually break them into their denominator and numerator. Now, the square root of 7, nothing I can do there. Okay, but we still have a problem because we have the square root of 4 on bottom. However, the square root of 4 is a perfect square. So that means it's just going to be 2, which clears up our problem. First of all, we don't have a fraction under the radical anymore. And second of all, we don't have a radical in the denominator. So the square root of 7 divided by 2. And that's it. Okay, so let's look at number 8. 2 square root of 3 over 4 square root of 3. So when I look here, so I got radicals in the bottom, but if I'm being really cautious, I can see that some things will simplify down. So just like multiplying, dividing, as long as they have the same index, you can kind of mush them together and pull them apart as you want. So adding and subtracting is the only strict one, okay? So what that means is we can actually break this apart into 2 over 4 times the square root of 3 over the square root of 3. Well, the square root of 3 over the square root of 3, that could really be 2 over 4 times 3 over 3, which is kind of nifty. Right? So 2 over 4, if we think about this as a simplification, that's 1/2. 3 divided by 3 is 1, so we have times the square root of 1. And guys, the square root of 1 is just 1. So that means we have 1/2 times 1, which gives us 1/2. Okay, so again, sometimes it's better to put them together, sometimes it's better to keep them apart. It just depends on the problem. Now, what happens if you can't do that? What happens if you have a division problem and they don't cancel out nicely? Well, that's when we do something called rationalizing the denominator, okay? So when we rationalize the denominator, we might be given something like this, 5 over the square root of 3. Now, I can't mush things together or pull them apart and hope that the square root of 3 disappears on the bottom. So what we do is we multiply by a fancy form of 1. Okay, and this is just a situation where we cannot change the value of the problem. So 5 has to always be 5. But if I was to multiply 5 by 1, it would not change its value. If I multiplied 5 by 2 over 2, it would not change its value. because that would be 10 over 2, which is still 5. It's just an equivalent form. So what we are doing is we are using an equivalent form to make this a better version of itself, okay? So because we have a square root of 3 on bottom, we are going to take and multiply both the top and the bottom. I need this bottom to be a perfect square. So square root of 3, if I want it to be a perfect square, the perfect square that I can make a 3 into is 9. If I multiplied 3 times 3, that would be 9. So I need the square root of 3 on bottom. But I have to make sure that this is a version of 1. Square root of 3 over square root of 3 is a 1. This is just a fancy 1. Okay, that's a 1, guys. So we now can multiply across the top. That would give us 5 times the square root of 3. We would just get rid of the times symbol. And on bottom we would have the square root of 9, which is nice because we know the square root of 9 is 3. So 5 square root of 3 over 3. Now do not be tempted to cancel these two things out. Okay, one's on the inside, one's on the outside. You cannot divide numbers if they're not in the same place. So this is simply 5 square root of 3 over 3. Done. Okay, so let's look at a more complex one, number 2. 3 minus square root of 2. Now this one's a little trickier because these guys are a married couple. They got to stay together. Can't get rid of one without getting rid of the other. Okay, so 3 minus square root of 2. So what we use is something called conjugates. Okay, so conjugates are simply the same exact numbers, but you change the middle sign. Okay, so we're going to multiply. Again, it's a fancy form of 1. We're going to use what I called now just conjugates. We're going to do 3 plus the square root of 2 and 3 plus the square root of 2. And actually these would create differences of perfect squares. They should look somewhat familiar to you. Okay, so 3 plus the square root of 2. Notice it's the exact same numbers. The only thing I've changed is that was a minus and now it's a plus. And the reason I want to do this is because it's going to get rid of those radicals. So on top we're going to distribute. 2 times 3 is 6. And then we're going to do 2 times the square root of 2. So 2 is an outside number, square root of 2 is an inside number. So we just write them side by side. On bottom we have 3 times 3, which is 9. But then we have to also do 3 times the square root of 2. So plus 3 square root of 2. Inside with inside, outside with outside. Then we would have negative square root of 2 times 3. So this guy times this guy. So that's negative 3 square root of 2. And then finally, negative, well, 2 times 2, because it's a square root and a square root, is the square root of 4. Now watch what happens down here, guys. Positive 3 square root of 2 and negative 3 square root of 2 equals 0. We don't have to write 0, right? It's just equal to 0. So we end up down here with 9 plus 0, and then here we have the square root of 4, which is 2. Well, 9 plus 0 minus 2 is simply going to be 7. So look at that. We got this nice number, and that's because we have these conjugates. Conjugates. There we go. And these are conjugates. So this conjugate allows us to eliminate the radical in the denominator. Okay? So these are skills you have to be familiar with because in just a moment now we're going to solve actual quadratics using these skills. Okay, so again, if you have any questions, make a little note, make a little asterisk, put them on the sheet of paper. We'll talk about it some more tomorrow. Okay, so now the real reason we looked back at that. Okay, so again, that was just a review of stuff you learned in Algebra 1 and Geometry. You did use it in Geometry, but the reason we need this is so that we can take square roots. Okay, so there are 2 reasons we use square roots. We like this method when there is no bx term. Okay, so notice it's just ax squared plus c equals 0. So when there's no linear term in the middle. So that bx term is called a linear term. The other time we like it is when it's already in perfect square form. Okay, so it's already got something with a square power. Instead of having to multiply all this junk out and use the quadratic formula, we can actually just use square roots. So if you look at this top example, 5x squared minus 23 equals 0, it fits this first pattern. It's missing a bx term. So the first thing we would do is we are going to add the 23 over. So when I add 23, that gives me 5x squared equals 23. Step 2 is to divide by 5. So when I'm dividing by 5, I end up with x squared equals 23 over 5. So now we have the x squared isolated, which is our goal. We want to get isolate the x squared. So now we're going to take the square root of both sides. And this is why we needed our rules, because when we take those square roots. Now, your Algebra 1 teacher may not have told you this, but I'm going to tell you this, and I expect to see this every time. When you take the square root of an x squared, that creates the absolute value of x. And this is just by a definition. But anytime you take the square root of a variable squared, it creates an absolute value. And then this is going to equal, well, little problem. We could break this apart and get 23 over the square root of 5, but we have that square root of 5 in the bottom. So this is where we need our skills at simplifying. So 23 doesn't simplify down. It's a prime number. Neither does 5. But we're going to need our fancy form of 1. So we're going to multiply by our fancy form of 1 here. And we're going to get the absolute value of x equals, let's see, 23 times 5. What's 23 times 5? It is 115. So the square root of 115, and then square root of 25, right, is just 5. So we've cleaned that up. Now, here's the next thing you need to realize. Okay, and again, I have got to see the absolute value of x. If I don't see that on your paper, we're going to have some trouble, okay? We don't want to lose points for silly things. The absolute value creates two equations, okay? So it creates a positive branch, meaning we just say, okay, it's just x. But it also creates the negative version, because absolute value is the distance a number is from 0. And if you'll recall, the distance a number is from 0, well, you could go left or you could go right. So like -3 and +3 are the same distance. Okay, so that is why you have a negative and a positive. You got one going right and one going left. Okay, so now good news is that one's solved. Bad news is this one needs to be solved. So we're going to simply multiply both sides by a negative. So that creates negative 115/5. Now at this point you could box them separately, or if you want to, you could say plus or minus the square root of 115/5. Completely your choice, okay? I would not count it wrong if you box them separately. Just make sure you solve it, okay? Now, our other example, that 2 times x minus 3 squared minus 5, the first thing we want to do is add 5 to both sides. So again, we're going to isolate the square part. Then we would want to take and divide everything by 2. So x minus 3 squared equals 5/2. So now we've isolated the square, so we take our square roots. So x minus 3 squared equals the square root of 5/2. Sorry about that. Okay, sorry about the little phone call. Anyway, so we took the square root of both sides. So now the left side equals the absolute value of x minus 3. You have to put that. Square root of a square, absolute value. Now over here, again we have our little problem. The square root of 5 and the square root of 2 are not, can't be simplified anymore. So we're going to multiply by the square root of 2. That's our fancy form of 1. Okay? Giving us the absolute value of x minus 3 equals, well, 5 times 2 is the square root of 10, and then we have the square root of 4, which is 2. Okay? So now at this point we create our two separate equations. So we say x minus 3 equals the square root of 10/2. That's one version. Then we say, okay, the opposite of x minus 3 equals the square root of 10/2. Notice I put parentheses around x minus 3 and said it's the negative on the outside. Okay? So over here we're going to have to add 3. Now, little problem, we can't add these two things together. So we just say 3 plus the square root of 10/2. Okay? Now over here you could distribute, but I would recommend multiplying both sides by a negative. It's going to make a little less work. So that creates negative 10/2. So really you're just moving the negative to the other side. And then again, all you have to do is add 3. So x equals 3 minus the square root of 10/2. And you could box those, or you could put it together as 3 plus or minus, because that's the only difference, the square root of 10/2. Alright, so number 11. I would like for you to try number 11. Number 11 is going to be 4x squared minus 25 equals 0. So pause the video, and when you're done, go ahead and turn the video back on to check. Alright, so first step, you would add 25 to both sides. Then you would divide by 4, giving you 25/4, and I would encourage you to keep this as a fraction. Fractions are much easier to take the square root of than decimals, okay? Then I would take the square root of both sides, and notice that would give me the absolute value of x. Make sure you have that step. And then the square root of 25 is 4, and the square root of 4 is 2. That's much easier than trying to work with 6 1/4, okay? Or 6.25. And then you create your two equations. So x equals 5/2 and negative x equals 5/2. Well, that one's already solved, so that means x equals plus or minus 5/2. Now you could put 2.5 as long as it's precise, but just make sure that you're being consistent, okay? All right, so number 12. 9x squared plus 13 equals 0. So go ahead and try that one again, pause the video, and when you're ready, turn it back on. All right, so again, start by subtracting 13, divide by 9, take the square root of both sides, again leaving this as a fraction, negative 13/9. The square root of x squared is the absolute value of x, and now notice here, negative 13, that's going to be imaginary, so the I comes out for the negative, keep the square root of 13, and then this 9 becomes 3. So this is really the square root of negative 13 over the square root of 9 if you need to see it, okay? So again, I square root of 13 over 3, create your two equations, so you should get plus or minus I squared of 13 over 3. Okay, and again, I need to always be seeing your two equations, and I need to see the absolute value sign, okay? All right, number 13, 2x plus 7 squared equals 9. So try this one on your own, and again, when you're ready, turn the video back on. All right, so for 13, your first step would have been to take the square root of both sides, as the square is already isolated. That would have created the absolute value of 2x plus 7 equals 3. Square root of 9 is perfect. And then two equations, guys. So 2x plus 7 equals 3. And then notice, it's still 2x plus 7, but I put it in parentheses and put a negative out front. So what this does is that actually makes it 2x plus 7 equals negative 3. Okay, so notice 2x plus 7 equals negative 3. And then it's just a matter of solving those linear equations. So here you would subtract 7, divide by 2. Here you would subtract 7, divide by 2. And you should end up with negative 2 and negative 5. So again, if you'll give me a little smiley face on these if you got them right. Okay, if you didn't quite get it, that's okay. Maybe make a little star or a little note or a frowny face or something that you know. I got to watch these, okay? All right, last little bit, number 14. It says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? Now, we actually have an equation for this. And what it is, so this is for a dropped object. So the equation is h of t equals negative 16t squared plus h sub 0. So that h sub 0 is a subscript, okay? And this h sub 0 is the initial height. It's where it's starting, okay? So in this case, the initial height is 50 feet, okay? So when we fill this in, we would say, okay, h of t equals negative 16t squared. That negative 16, it has to do with gravity, okay? And that's for here on Earth when it's in feet. And then we'd say plus 50, because 50 is the initial height. Now, we want to know when it's going to hit the ground. Hit the ground is the height we're looking to find. So h of t is the height we're trying to find. So we simply say, okay, what is it going to look like when h is 0? So now this is just an equation that we can solve. So we could start by either subtracting 50 or we could add 16t squared. It's our choice. I'm going to actually add 16t squared so I don't have to work with those negatives. And then we would take and divide by 16. So t squared equals 50 over 16. Now notice, I am not actually simplifying this because 16 is a perfect square. That's actually kind of useful to me, especially here in a minute when I'm going to take the square root. So that's going to give me the absolute value of t. Now the square root of 50 is going to be 5 square root of 2. The square root of 16 is going to be 4. Okay? So what we end up with our two equations. So we have t equals 5 square root of 2 over 4, and the opposite of t equals 5 square root of 2 over 4. So we have negative 5 square root of 2 over 4. Now let's think about this. We're talking about time, and I don't know about you, but I don't usually talk about time in terms of square roots. So in this case, it would be more useful to have a decimal. So if I get my handy dandy calculator here, well, that's going to be negative time. So I'm not even going to waste my time working with that one because time can't be negative. But 5 square root of 2 over 4, well, that's useful. So 5, we're going to use the fraction key, F1, 5 square root of 2 over 4. And that's about 1.77. We typically try to round to 2 decimal places when we can. So 1.77, because the 6 would round up due to the 7 afterwards. So how long does the container hit the ground? Well, in about 1.7 seconds. So this is a context problem. Context problems deserve a context solution. So the container will hit the ground in about 1.77 seconds. Now, little note, you didn't actually have to simplify the square root of 50 over 16. If you had actually typed that in as it is, 50 over 16, and then done the square root of that, notice we would have got the same answer. Okay, so it just depends on what you're doing. If this was a skill problem where you had to simplify, you would want to simplify. If this is a word problem where decimals are more or make more sense, then you would just use the calculator and simplify it that way. Okay, so I want you to go ahead and try number 15. If you get stuck, my advice to you is to draw a picture, and when you're ready to see the answer, turn the video back on. Alright, so first of all, I hope you noticed that I drew a picture. Okay, so I knew the width and that the length was 2 times the width. So I did 2 times W for the length instead of putting L. Well, I also knew that I was looking at area. And since we're looking at area, area is length times width. So I said, okay, well then I have to do W times 2W, and that has to equal 72 square inches. So now it was just a matter of doing, alright, W times 2W is 2W squared. Divide by 2, take the square root, that creates the absolute value, and notice we get 2 answers, 6 and negative 6, and notice I've tossed away negative 6. We can't have a negative length or width, so it doesn't make sense in the context of the problem. So 6 was kept, which means if I want the dimensions, the width would be 6, the length would be 2 times 6, which is 12. So since W equals 6, 2W would equal 2 times 6, we would simply say the rectangle is going to be 6 inches wide and 12 inches long. Alright, that needs to go in the notes section of your notebook, and then you need to do your homework, which in this case would be 2.4, I believe it's practice B, okay?